So the first major category we're going to focus in on is our fossil fuel usage, just because I feel as if this is the biggest one that people have conversations about and over, and especially ever since electric vehicles have really become a big push within today's society. So fossil fuels. This is really focusing in on 3-1 and 3-3, but basically by the end of today, you should be able to explain the types of fossil fuels that we use today as a society, list the possible negative effects that that the use of these fossil fuels have within our planet, then also give examples of how we um, or what sort of products we find fossil fuels within that maybe isn't just the run of the mill, oh, it's in my gasoline that powers my car, things like that. So make sure you have your whole notes out in front of you and that you're ready to go. So, what is a fossil fuel? Well, fossil fuels are natural fuels such as coal or gas, even natural gases, that are formed in our geologic past from the remains of other living organisms that have since decayed and through intense heat and pressure have now transformed into something we can use as a fuel. Um, Fossil fuels are what are known as non-renewable resources. So resources that have been on our planet since the moment the planet was actually created. Um, and as soon as they're gone, they're gone. Okay, some examples of fossil fuels that you probably are more familiar with these days include coal, petroleum, natural gases, which we use to heat our homes, and then things like that. So this is a quick little video that helps explain what are fossil fuels, how they formed, when they formed, things like that. So yeah, watch and let's see. So where did fossil fuels come from? Well, the fossil fuels that we're actually using today originally were organisms that passed away during the Archean eon. So from about 4 billion to 2.5 billion years ago. This is all organic matter produced by photosynthesis because at this point in time we didn't have a lot of multicellular organisms that weren't plants, but they're being crushed down thanks to plate tectonics and actual development of the plates and other geoscience processes that were creating fossil fuels, a lot of volcanic eruptions, earthquakes, things like that. So this is why we can say that fossil fuels are a non-renewable energy source, even though they're made of an organic sort of material, because it took 4 billion to 2.5 billion years for what we are using today to actually start the process of decomposing into a fossil fuel. So it's not a renewable resource, even though, yeah, 4 billion years from today, whatever organisms are on this earth could technically use our remains as a form of fossil fuel. But they have to wait about 2.5 billion years from now, which is a really long time to wait. So, Champ's expectations. So if you are moving forward into independent notes, here are your expectations. If you are going to continue with PowerPoint notes, then just hang in for a second and we will get there. So I think the biggest question, or I should say concern as well, that comes down to fossil fuels prior to the issue of their emissions would include how we actually get fossil fuels in order to use them today. There are two different ways that we can extract fossil fuels from our planet, and that is either through mining or through drilling. So mining is the process of digging, scraping, and exposing buried resources on the surface of the earth in which we all can stand. Drilling is the extraction of liquid or gaseous fossil fuels by forcing these fuels to the surface. This can be done both on the surface in which we live and stand on today, or the surface which includes the ocean floor. So you'll see different types of drilling, whether it is the middle of the ocean sort of drilling, or whether it is out in the middle of a field sort of drilling. So yeah, those are the ways that we extract fossil fuels from our planet. Now, with mining, there are two different ways that we mine, and then drilling I'll get into. So the first way, which is one that we spoke about when we talked about our minerals back in our mineral unit, this is surface mining. So this is strip it mining, or the removal of mountaintops, where you are digging at the surface layer by layer by layer by layer to see what you can get, and you constantly are building down. Some of the possible effects, both short-term and long-term, that can come from surface mining. Short-term is the excess rock and soil causing streams to divert. So obviously, as we are digging, we need to put all of that extra rock and soil somewhere, and typically it's not that far from the actual dig site, because then it gets really expensive to move it, to where they go and they just kind of put it up in these little mini hills and things like that. I think of where we put all of our snow in the winter. By just moving the snow, we're moving all that rock and sediment, but then what happens come spring? Well, the snow melts, and then all the rock and sediment melt with it and move with it, because that's just how it works, possibly causing for a stream buildup or a diversion of the spring. And then the issue with that comes into flooding or lack of water to certain areas that really, really need it, which then in the end completely alters ecosystems. As you can see from this picture, we've essentially taken away all of that ecosystem from any sort of animal or plant species, to where then they need to now go find other places to live and things like that. Long-term effects. So these are the things that couldn't necessarily be fixed quickly. Some long-term effects include poor soil to only support exotic grasses and things like that. When I'm saying poor soil, I mean it's not as nutrient rich to where native species of any sort of plant could really take off and do well. If we're taking out those minerals that once fed these organisms, they just can't be supported. But something a little bit more hardy that really doesn't need a lot of nutrients in order to survive could really do well. Excuse me. Um, to where then if they are introduced to this environment and this ecosystem, they take over, and it is a complete invasive species sort of takeover where then you don't have the same sorts of competition necessary in these ecosystems to where other species may die out as a cause of this. And then another long-term effect would be the actual burying of valleys and water systems. So by moving that rock and sediment, you could be putting it onto another ecosystem, which then you're now ruining two ecosystems, getting rid of water for one potentially to where now those organisms don't have water, which is necessary for life and things like that. So it's a big issue on so many levels. The last problem with surface mining is that it's very invasive. There's not a lot of simple and easy ways where you do the least amount of damage. It's like the way you cause the greatest damage and environmental disturbance in what sorts of organisms will or will not stay due to humans being there, or the fact that we're taking away the necessary nutrients that they need in order to survive, just things like that. It's very detrimental to an entire ecosystem. Um, Not to mention the effects that they have on humans. So when we are surface mining, we could cause a variety of catastrophic events for humans, including mudslides. If you're taking away rocks, then the rock is far less steady to where mudslides and landslides can occur because there's nothing to super support those rocks that are now in these big piles somewhere. Flash floods, if you're taking away the proper nutrients, or you're taking away the nutrients and then that in turn takes away the natural plants that would occur within that soil, you could have the possibility of flash floods, meaning that we get enough rain to where it's not being absorbed into the soil anymore because there's nothing to absorb it, to where it now just pools. So not great. And then because of any of those sorts of disturbances, plus the runoff and chemicals used in actual surface mining, we can then in turn just pollute our own drinking water. Which can cause then lung disease, cardiovascular disease, kidney disease, diabetes, hypertension, and all of that plus some. It puts us at a larger risk for cancers and other non-curable diseases. The second form of mining that can be done, would include underground mining. And again, it's just as it sounds. It is digging underground to get the minerals or the ores that you wish to then sell for profit. They come with their own significant concerns. So the threats that are posed to the health and safety of the actual miners themselves increased significantly. I didn't think that when I was Googling, like, oh, have there been any like mining deaths recently? I didn't think I would actually get the results that I did. But within the United States alone, there were 77 fatalities, meaning 77 people lost their lives within actual mining processes between the years of 2010 and 2013. I'll have to look up and see if there are any more recent numbers, but 2010, 2013, yes, most of you were barely alive, if at all, but 77 people lost due to mining incidents seems ridiculous for 2010. So that. Underground mining also comes with a very significant cost. It costs a lot of money in order to hopefully provide people with the right training, to get the right equipment that can actually dig through all of this rock and get out what they actually need and things like that. Yeah, along with some other possible health concerns that people would have due to underground mining, a lot of miners have what are called black lung disease or pneumoconiosis. Essentially, it's called miner's lung, where about 10,000 former miners died between 1990 and 2000. So from the time I was born until way before you were born. But that's a lot of people because of these health concerns. Also, some environmental concerns include the collapse and subsiding, leading to affecting ground flow or water flow and things like that. So first of all, just the fact that mines can cave in. Secondly, if a mine were to cave in, it could potentially divert water. Plus, then if you're trying to get through the water because there's fabulous ore there, you then are diverting the stream intentionally, again, leading to similar issues as with surface mining and things like that. It's just, humans are awful. But that's underground mining. The final way that we can actually extract any sort of fossil fuel would be through the process of oil or gas drilling. So this is where we are physically drilling into the Earth's crust, just enough for pipes to make their ways through, not humans. But it comes at a very significant cost, both financially and health wise. So obviously if you look at the top picture, you'll see like drilling out in the middle of the ocean has so many risks for the pure fact of, God forbid, one of those were to explode, there were to be a leak anywhere, you are leaking that gas or oil straight into your ocean. So that the bottom picture is of surface drilling, where if one of those were to explode or leak, you are then leaching all of those oils and gases into that rock layer, causing imbalances within certain chemicals and things like that that are necessary, again, just to support life, things like that. People who work within this field, I wouldn't say have far less like health concerns as compared to the underground mining, but this is a big deal job, just because if one of the drilling platforms in the middle of the ocean were to explode, there's nowhere for these people to go. Or similar to surface drilling, where if it explodes, you only have so far you can go at the rate that humans can run. Things like that. It's just not good. So, yeah, excuse me. And then finally, they are trying to use new technologies, and by new, I mean within the last couple of dozen years, but hydraulic fracturing or fracking, which we know it as really well up here in North Dakota, which then causes its own environmental concerns that we just don't have enough data to truly support that, either positively or negatively. So, yeah, this is kind of where we're at with extracting fossil fuels. Now, what do we use fossil fuels for? So beyond just transportation, filling up our cars, our buses, things like that, we also use fossil fuels for electricity to power our homes. In every single plastic item that you own, My pens and pencils all have some sort of fossil fuel petroleum byproduct within them to be able to actually make them what they are. Nylon, so any sort of stretchy material, heating, obviously burning coal and things like that. Candles, wax. If you get organic beeswax, sweet. If you get just paraffin, that's fossil fuels. Textiles, in order to make the textiles, and then some of the textiles themselves. As I said, the transportation, but things that you don't necessarily think you're going to find byproduct of fossil fuels in would be like lotions, beauty products, cosmetics, things like that. But if you were to actually read the ingredients on any of those things, there's a petroleum byproduct somewhere in them. So not not necessarily in places you would always think. So this is your exit slip essentially. Um, how would, like, if all the fossil fuels were gone in this world, because as we know from today's media, we are running scarcely low on fossil fuels to where it's causing a lot of conflict and other concerns. But if fossil fuels were to be gone, how would this affect you? What products would you no longer to be able to go to the store and purchase? And then does knowing this sort of a thing, or how much risk and concern comes with any of the extraction processes, does this change your mind in any way on maybe your personal uses of fossil fuels? Now, I'm not saying that everybody needs to go out and buy an electric car today, but think about what are some other things, because I know I can't afford an electric car right now, but there are different things that I could cut out, or different things that I could change the way I use them or reuse them, sort of a thing. What are some ways that maybe I could change my small little world to where I have less of a fossil fuel impact upon the world? So think of that, answer it when you get a chance. Thanks, guys.